In this lesson, we're going to look at what are called significant figures as well as scientific notation. And we're going to look at what numbers really matter when we're writing an answer. So, significant figures, or a significant figure, is a number that matters when we're writing to provide accuracy or precision in a calculation or a measurement. In order for it to be significant, it has to follow one of these rules. Either it needs to be a 0, 1 through 9. So 1, 2, 3, 7, 8, 9, one of those things. If it's one of those, it's significant. It counts all the time. 2, if it's a trap 0 or a sandwich 0, which means it's between two non-zero numbers. So 108, 305, things like that. And then finally, if it's a trailing 0 and you have a decimal point in your answer, it only works if you have a decimal point. So if you have 3.20, then that 0 is significant. But if you just had 320, it's not. We're going to look more than that. So here's my example. I have 404.00. So my 1 and my 4 are non-zero numbers, so they count. This 0 right here is trapped, so it counts. And then these trailing zeros count because there's a decimal point right there. So again, our numbers 1 through 9, they matter or they count. So here are my examples. So I have 1, 2, 3. So that means I have 3 significant figures. Here I have 4, 5, 7, 6. I have 4 significant figures. My last one, 9, 7, 4, 3, 5. So there's 5 digits and all 5 are significant. That one's the easy one. So these are numbers again between 1 and 9. Okay. Oh, sorry. Switch slides. Trap zeros always matter. These are zeros between zeros 1 and 9. And then they're also known as sandwich zeros, okay, or captured zeros. Okay. So if you notice here, I have 1, 0, 3. So my 1 and 3 are significant because they're non-zero numbers, but my 0, because it's trapped, is significant and it's 3. Here I have 9, 0, 0, 0, 4. So my 9 and 4 count. So that's 2 significant figures to start. But because these 3 zeros are in between, they have to count as well. And so my answer is 5. And then I have 0.4005. Okay, because I have a 4 and a 5. Those are significant. And then I have 2 zeros caught up between them. They're significant. This front 0 doesn't count. We're going to talk about him in a minute. So I have 4 significant figures. Okay. Number 3, leading zeros never matter. These are the zeros in the front, and they're usually dealing with decimals. Okay, when we're dealing with decimals, we're going to see that. So example 0.0003 has 1 significant figure because my first 4 leading zeros don't count. Okay. Even there's a decimal, my leading zeros don't count. They never count. Okay? So here I have 2, a 1 and a 2. There's 2 significant figures that are non-zeros. And then my 2 zeros in the front don't matter, so my answer is 2. Here I have 0.324. Okay? So my 324 doesn't count. Or sorry, my 324 do count because they're significant because they're non-zero numbers, but my 0 in the front doesn't count. And so my answer is 3. Okay, and then here I have 0.0004. 4 is going to count because he's a non-zero, but all the zeros in the front don't matter, so my answer is 1. Trailing zeros do not count. These zeros are at the end. So, for instance, I have 10400. Now I have a 1 and a 4. They count because they're non-zero numbers. I have a trap 0 that counts, okay, between my 1 and 4. But then I have 2 ending zeros. So I have 3 significant figures because my last 2 zeros don't count. So hopefully take a minute and look here and see if you can figure out how many significant figures there are. In my first one, I have a 130. I don't have a decimal point, so my last zero doesn't count, and I just have 2. My next one, I have 3 non-zero numbers that count. I have a trap 0 that counts, but I have 2 trailing zeros that don't count, so my answer is 4. And then finally, I have 6, 5, 7, 0, 0, 0. Okay. My first 3 numbers are significant because they are non-zero numbers. My last 3 are not significant, so I only have 3 significant figures. So this is where it gets tricky, and this is where people get lost, is that decimal point. Trailing zeros only count if there's a decimal point. Okay? They make a 0 count. So here, earlier I had 10400 and we stopped, and I said I had 3 significant figures. Now, because I put a decimal point in, my 2 zeros right here count, and this 0 counts. And it has 6 significant figures, even though there's 3 trailing zeros. And the reason being is that a decimal point is giving us the assumption that somewhere along the line on that decimal, there is a non-zero number somewhere. We might not see it. It may be, 37 spaces down, right? We're not going to write all that down, but we're making the assumption that there is a non-zero, and so it's almost like that these are sandwich zeros. We just don't see the other side of the bread. Okay? So let's look at our example, 270. Okay, because I have a decimal point here, we're making the assumption that over on the right-hand side, there is a non-zero number somewhere and making that 0 trapped. And so my answer is 3. Number 2, again, I have my 153. Those are significant. This decimal point is making these 2 zeros significant because it's saying somewhere along the line after this decimal point, there is a non-zero number that we just can't see. And so my answer would be 5. My 4 and my 1 are significant because they're non-zeros. This 0 is significant because he's trapped. Okay. This 0 becomes significant because there's a decimal point. And again, that decimal point is making the assumption that somewhere in the decimal section, there is a non-zero number after this 0 that's going to cause it to trap. So my answer is 4. Scientific notation is a way of noting a really big or really small number. We use scientific notation a lot in chemistry because of the fact that we use really small things that add up very quickly. So we're going to use something later on. You're going to see that has scientific notation very often because there's a lot of them. Or something so small, we have to write it. And we don't want to write a whole bunch of zeros before we get to our number. So to write in scientific notation, we move the decimal until you have a number between 1 and 10. So 1.7, 9.3, 8.6, something like that. You're going to count how many spaces or spots you moved. So you're going to bounce, I always say bouncing, till you get to that thing. So if you're at 1,523, okay, you're going to bounce over between the 1 and the 5, 1, 2, 3 times. And we're going to see that. The number of bounces becomes your exponent. So if you bounce 3 times, it's 3. If you bounce 7 times, it's 7. If you bounce 23 times, it's 23. Now, finally, we have to determine, is our bounce positive or is it negative? If we bounce to the left, it's positive. It's a really big number. If we bounce to the right, it's negative and it's a really small number. Okay? So here's my example. I have 67,000. And here's my decimal point. If you don't see a decimal point, you make the assumption that the decimal point is at the end of a whole number. And I'm going to bounce over 1, 2, 3, 4, because I want to be between the numbers 1 and 10. So 6.7 is between 1 and 10. Okay, so that's going to be my first part. And then I bounced 4 times. So I'm going to put times 10 and put 4. And then I have to determine, how did I bounce? Did I bounce left or right? I bounced left, so my 4 stays positive. So let's look at some mathematical operations. When adding and subtracting, use the least number of decimal places. So I have 1.23 plus 4.5. If I add them together, I get 5.73. But if you notice, my 4.5 has 1 decimal place, so my answer has to have 1 decimal place. So try these out. Pause the video, and then you can see your answer in just a second. When multiplying and dividing, you use the least number of significant figures. So adding and subtracting, it's the least number of decimal places. Multiplying and dividing, it's the least number of significant figures. So this can be before or after. So here my example is 1.23 times 4.5. I get 5.535. But if we notice, I have 3 significant figures in the left and 2 in the right of my factors. So I'm going to put my answer into 2, and I'm going to make it as 5.5. Again, try these right here and see what you get. So pause the video. So here's our let's try, and these are in your notebook. So you have 4.1 minus 2.12. I have 2, I am doing subtraction, so I'm going to do the least number of decimal places. So when I do this, I get 2.18, but I have 1 decimal place. Here I have 2, so I can't use 2, I have to use 1, so my answer becomes 2.2. Okay, let's try this one. You have 8.75 plus 2.210. If I do the math, I get 10.960, but I want to look at my significant or my decimal places. I have 2 and I have 3. 2 is the least amount, so I need 2 decimal places here. So my answer becomes 10.96. Here I'm going to multiply. So when I multiply these two, I get 9.116. But here I have 2 decimal places, or 2 significant figures. Here I have 3. So my answer needs to be into 2, which is 9.1. Here I'm going to divide 8.75 by 2.210, and I get 3.595. Okay, and then note, I have 3 significant figures here. I have 4 here, so my answer needs to be in 3. Okay, and my answer is 3.60. Please remember your rounding rules. Okay, if it's 0 to 4, your number that you're rounding stays the same. If it's 5 or through 9, that number is going to go up by 1. All right, and then writing in scientific notation. Here, I'm going to assume my decimal point is back here. I'm going to bounce over 1, 2, 3, 4, 5, 6, 7. So I'm between 2 numbers, or so I'm between 1 and 10, 9.75. And then since I bounced to 7, and it's going to be positive because I bounced left. Here, I'm going to move my decimal place over 1, 2, 3, 4, 5. So my answer is going to be 5.67 times 10. I did 5 bounces, and since I bounced to the right, it's going to be negative. So that is all you need to know about significant figures and scientific notation.